Summary. 1. Alternating current AC. If the magnitude and direction of current changes periodically with time, then the current is said to be an alternating current and the corresponding voltage is said to be an alternating voltage. E equals to E naught sine omega t. I equals to I naught sine omega t. E stands for instantaneous value of EMF applied. E naught stands for maximum value or peak value of EMF applied. I stands for instantaneous value of current. I naught stands for peak value of current. Omega t stands for phase. Omega stands for angular frequency. Omega equals to 2 pi f equals to 2 pi by t. F stands for frequency, t stands for time period. 2. Alternating current produces mainly heating effects. Hence, hot wire meters are used to measure AC currents. 3. Other forms of alternating voltage. A. Square wave potential. B. Triangular wave potential. C. Mixed wave potential. 4. Difference between DC and AC. Direct current, DC. A current whose magnitude and direction does not change with time is called direct current. Alternating current, AC. A current whose magnitude and direction change with the time is called alternating current. The frequency of DC is 0. In India, the frequency of supplied AC is 50 Hz. In US and Canada, commercial electric power distribution system always used a frequency of 60 Hz. The apparent and peak values of DC are equal, hence it is comparatively less dangerous than AC. Its peak value is √2 times the apparent value, hence it is more dangerous than DC of same voltage. Energy loss is more in its transmission, hence it is difficult and expensive for long distance transmission. Energy loss in its transmission is less, hence its long distance transmission is easier and economic. Transformers do not work for DC. A transformer can convert high volts at low current into low volts at high current and vice versa. It can be controlled by ohmic resistance, thus energy loss is very high in the form of thermal energy. It can be controlled by choke coil. Energy loss is very less. Symbol for DC source is and the directive to negative terminal. The source is represented by the symbol polarity change regularly, hence direction is not represented. The markings on the scales of the apparatus measure strength of current and voltages are equidistant. The markings on the scales of the apparatus measures strength of current and voltage are not equidistant. Source of DC are battery and cell. Power stations can produce AC current. 5. Average value of AC over a complete cycle is 0. 6. Average value of AC for half cycle is average I equals to integration from 0 to t by 2 I dt by integration from 0 to t by 2 of dt. Average I equals to 2 I naught by pi for positive half cycle. Average I equals to 0.636 I naught. Average I equals to minus 2 I naught by pi for negative half cycle. Average I equals to minus 0.636 I naught. 7. Average value of alternating voltage for half cycle is average E equals to integration from 0 to t by 2 of E dt by integration of from 0 to t by 2 of dt. Average E equals to 2 E naught by pi equals to 0.636 E naught. 8. RMS value of current. IRMS. It is also called as effective value of current or virtual value of current. IRMS equals to root average I square. Average I square equals to integration from 0 to t of I square dt by integration from 0 to t of dt. IRMS equals to I naught by root 2. ERMS equals to E naught by root 2. IRMS equals to 0.707 I naught. ERMS equals to 0.707 E naught. 9. Average I equals to 2 of root 2 by pi. IRMS. Average E equals to 2 of root 2 by pi. ERMS. 10. Impedance Z. The property of the conductor which opposes AC is called impedance. It is denoted by Z. Z equals to R plus JX. Modulus of Z equals to square root of R square plus X square. Z equals to ERMS by IRMS equals to E naught by I naught. Ohm's law, ERMS equals to IRMS Z. E naught equals to I naught Z, where Z equals to square root of R square plus X square. Therefore, X is reactance. 11. Reactance X. A part of impedance in which voltage and current are not in phase is called reactance. XR equals to 0. XL equals to inductor reactance equals to L omega equals to 2 pi FL. XC equals to capacitive reactance equals to 1 by C omega equals to 1 by C of 2 pi F. F equals to 0 for DC. F equals to 0. F equals to infinity. XC infinity 0. XL 0. Infinity. An inductor bypasses the DC but offers finite impedance to the flow of AC. A capacitor can bypass the AC but blocks DC.